Welcome to Techno Education. In this video, we will talk about bending in beams and shafts and shear and bending moment diagrams in general. We'll only be covering the theoretical part, while for demonstration on how to draw shear and bending moment diagram, follow up our next video. So let's begin. Beams and shafts are important structural and mechanical elements. Beams have numerous applications, whether it's a bridge, an automobile, or any other mechanical system. Generally speaking, beams are slender and they are loaded perpendicular to their longitudinal axis. They are long, straight, and mostly they have a constant cross-sectional area. Examples include wing of an aircraft, axle of an automobile, a crane boom, and many more. Beams are classified based on their supports. Number 1, simply supported beam, a cantilevered beam, and an overhanging beam. In simply supported beam, there is a pin joint on one end and a roller support on the other. In cantilevered beam, one end is fixed and one end is free. In overhanging beam, one end is supported by a pin joint, while there is a roller support not exactly on the end but under the beam so that it has a free end. These applied loadings results in two types of reactions on the beam. One is an internal shear force and one end is a bending moment that is exerted on the beam. These force and moment vary from point to point along the axis of the beam. So what do we do in shear and bending moment diagram? We express this internal shear force V and bending moment M as a function of their position along the axis of the beam. What's its advantage? Shear and bending moment diagram helps us determine the maximum bending moment and shear force to the engineers or whatever, the constructors or whatever, and with this maximum bending and shear force, what they do, they design the beam according to this. Like if there is a maximum bending acting on one end or a shear force, then what they can do, they add more material to reduce its effect. So this is an advantage of shear and bending moment diagram. Exactly what I said, it is used to decide place of reinforcements in beam, proportion size of beam at various points along its length. So to plot the diagram, first of all decide an origin and a position x in the x direction. Origin is located at left end of the beam and a positive x direction is to the right. So this is basically a convention to draw shear and bending moment diagram. So what do we get in the end? We get a function of shear and a bending moment diagram, but we see that in many cases where there are multiple supports instead of two, there are discontinuities on the slope of the graph at the points where distributed loading changes or where concentrated forces or coupled moments are applied. So this internal force and moment can be determined for different region. So where there is a concentrated force or couple, we divide the complete beam into these different regions, and then we calculate the individual shear and bending moment, and then we draw the complete diagram in the end. So that was pretty simple. This is all about the introduction or the theoretical portion of shear and bending moment diagram. In the next video, we will talk about the demonstration. We will solve an example to get a better idea on how to draw a shear and bending moment diagram. If you like the video, please don't forget to subscribe to the channel.